All right, so today I just want to do a design debrief and talk about my journey into LEDs. So at first, this seemed like a super daunting task to me, and it was super overwhelming. I didn't want to mess with any LEDs, but more and more of my projects could have benefited from the addition of LEDs. So finally, I decided it was time to dive in and to figure it out. So initially, what kind of spawned the idea was I had some leftover diffusers, and these diffusers came from an old kitchen LED light that the battery had went out on, and it wasn't repairable. So I salvaged these diffusers because I was like, oh, I'll probably be able to use those one day. And so that day finally came. And when I was studying the mechanism or the hold function, whatever you want to call it, I noticed that it had the ridge. So I 3D designed this very simple counterpiece to where it can slide on, and once it's able to slide in, okay, let's try, then it just holds. So this is kind of what I started with, but then I had found a cheap LED light from a store. It was just a few dollars, like $5, and I purchased it. And this is, kind of try to put it together. This is essentially what it was. And the front diffuser is just a very like milky type of diffuser. Let's see. So very soft diffuser. It really diffuses the light, very nice. And in here is just a simple strip. It's got the LEDs. It's got the IR sensor. Came with a remote, simple effects, and the end is just a USB type A 5-volt regulated. So very simple design. And then the back piece stand, simple stand, and it has two configurations. So it's got a bottom and then a side where you can just mount that on the side, and then you have a side view, or if you mount it on the front, you have the front view. So I really like that form factor. So I set out to recreate this. So my first initial prototypes and kind of getting the sizing right of everything. So I 3D printed this diffuser just to kind of get the rough size and get an understanding of also the light transmission from the different 3D printed elements, because I hadn't tried to 3D print diffusers before. So I had to play with thickness, and I found that about half of a millimeter, so 0.5 millimeters, gave me a nice sweet spot between diffusing and allowing enough light to pass to where it's not completely blocking the light. So I stuck with that, and then I designed a pop-in cover. So basically I've got very tiny locking tabs on the sides and the top, bottom, and this just push in. So this was my 3D printed recreation. This was one of the attempts. This one failed. If you can kind of notice, it got warped. It lifted off of the print bed and it got warped and kind of bowed, and this side just kind of got smushed together a little bit, so it just wasn't a good one. But nonetheless, the mechanics of everything still work pretty well. And so the front was designed to just pop in, just come in here. Oops. Because once you get it to lock on those corners, oh, I gotta get it over this tab. So I had locking tabs on the bottom also. I was using the Jow ESP32. I can't remember if it was a C3 or the S3. One of those variants. Okay. And so just locking that in. Whoa, 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 whoa. So the lip is very small. So that's why it's like pushing past it. So you gotta get it right on the money. And then once you do, oh, okay. All right, there we go. Okay, so now solid, and pop that through. So you get the general idea. This was the concept I was rolling with. I wanted to kind of do a variation of the design. So what I did was I kind of built a platform for a 45-degree angle triangle piece that I could print separately, because I was printing this flat with this orientation. So that way I don't have to worry about any other supports or anything other like that. Try to minimize supports in all the designs. So with this back piece, I created kind of like a lock and key system to where I printed a separate peg that would lock in and then create a back platform that I could just create a simple mount on. And then this is one of the mounts that I recreated versus the, let's see where the original is. Here's the original. So pretty similar in shape and concept, dimensions a little bit different, but overall just trying to understand the premise of the design, how to improve it, how I feel it can be improved. And I kind of didn't like where I was going with this direction. Here's another failed print. I was playing around with the chamfer and the bevel, but because I didn't have my print settings tuned in, the top section is shinier because it is printing faster or at a hotter temp with less cooling, and then the rest is the matte color because it's printing at a slower speed or at a cooler temp. Many different reasons, but it's mainly an optimization issue. But so I was having a lot of issues with these coming up off the bed, so I started adding a brim. And once I started adding a brim, it did make things better. And I did like the concept. I mean, it did look super clean to me. And what I did end up eventually getting to was this design. And this is a fully functional design. And I was able to print my logo in the center with the pass-through being just that piece, since this is 0.5 millimeters, and the rest is maybe about 1 millimeter or so. So just a little bit more thickness. And of course it's black, so the light won't pass through here. It only passes through the logo piece. I didn't create, so here's what's funny on the inside of this guy. It's kind of archaic, and there's a lot of things I didn't think about, like how I was going to close the back, for instance. So I didn't put any locking tabs on this one. And the little jowl, this is a C3, ESP32 C3. So this little board, the antenna, let's see if I can get a good angle of that. The antenna is mounted on the top here. It's kind of like a sticker. So I basically stuck it to the top of there. However, I didn't create a way to lock in the board, really. I just created like kind of like a guide for it to like snap in. There's just 4 corners. I basically just took the 4 corners of the board, the perimeter, and I extruded the corners out, gave them about 0.2 millimeters of clearance, and then extruded the rest out so that there was some type of a block from keeping them from shifting around too much. But I didn't account for the up and down motion. So when you plugged in a USB-C cable to power it on, if you tried to unplug it, or if you plugged it in more than once, it would start to come off and come loose, and then I would have to undo everything. So that's why I kind of ended up using this sticky double-sided tape stuff to just seal up the back for now. But the whole premise is that I didn't really consider a lot of things, so I had to scrap this design. And I thought, you know what, let's go all together with a whole different design. So I thought I would print a modular snapping together design, and so this is what I came up with. The USB-C port was here. I had to use a adapter that I had. It was just like a simple, like one of these guys that's just a right angle, because I couldn't get the board at a good angle. So this is kind of one of my little QT pies. This is a ESP32C3. However, it's got the power add-on backpack deal, but I've got to resolder this data line for this LED ring first. But yeah, that's a different project. But this is what we came up with. So same kind of concept as the original design. I had 4 posts. I had to break them off because I pulled everything out of it. I gutted it once I didn't decided. This was like a thick boy also. I don't think I needed it this thick. Absolutely did not need that. But what I did was, this is what I 3D printed. I 3D printed this with some PETG translucent filament, and I like the result. It's really not bad in terms of diffusion. It diffuses the light pretty well. To me, you can obviously still see the texture, maybe a little bit. Oh, there we go. So you can still see the texture of the print, which that's fair. However, when I had some translucent material that I bought from like a hobby store or something. It was just like a poster of it, and I just cut it into these strips, and I just kind of tucked it into the side here also. So I just tucked that in there, and then same thing for the other. Just tuck that in, and that helped a lot to me. That broke up the light a lot more and was giving pretty pleasing results, considering the fact that this design was pretty much 100% 3D printed. And same thing with the back here. The back just popped off, and then that slides off, and then this, oh, very tight. Okay, I don't think that wants to come off, but this in theory slides off. So, but part of the reason why we scrapped this design, just wasn't in love with it. And often that's what I find with the designs, is that if I'm not in love with it, I end up scrapping it or going back to the drawing board or going back to plasticity to model a different variant or version, because until I'm like in love with it and I can't stop touching it, that for me personally is when I know I've reached a good design point, is when I can't stop touching it, because I am so excited by its state that I just want to keep touching it, you know, and that's how I know I've arrived. I did try some fuzzy skin variants. This was kind of cool, just playing with the texture, but I was getting some strange surface defects, most likely from the internal structure, because I was printing this horizontally with supports. So because I had these cutouts for the Zhao ESP32s, and then I had 2 pegs along with the cutouts, and I think I wasn't even printing this with supports, so, or maybe very minimal supports, if that. But yeah, just didn't work out very well. Another failed print, but this is where we started to get closer to end game. So I kind of went back to the drawing board entirely, redid the shape, redid the structure, and minus what happened here, I'm guessing under extrusion or some strange, yeah, something strange happened here. So we had to scrap this. You can still see a little bit of the brim left on there. I didn't completely pull the brim off, but the brim was huge in ensuring that these didn't come out warped and came out pretty much straight as possible. And then the evolution kind of evolved to our pretty much final state, which is this guy. So I ended up switching to a D1 Mini, which is a ESP8266, and it's arguably a little bit slower and doesn't have all the features of the ESP32. However, I have found the reliability to be rock solid. So I haven't had any issues with dropouts or any issues with connecting to Wi-Fi. And so I've really been liking these. And I ended up buying a 10-pack. I only have 4 left currently, because I made a temp sensor. I built a remote monitoring OLED home assistant sensor, and then I have 2 light boxes. So on my desk is the final version that I went with, the final design. I printed that, and everything locked, clicked, snapped perfectly. I was in love with the design, and this one accounted for all the things such as because this was the issue with this one, why I ultimately had to scrap it. I was playing around with the idea of putting stencils in with different initials so that I could offer that as a service and do like different initials. However, the issue with this one was that if the stencil wasn't pushed all the way up against the diffuser, it created some random ghosting effects and just didn't look as pleasing, as aesthetically pleasing to me. So I took that into consideration, and the biggest thing that I had to scrap this design for was the plugging in issue. That to me is like a non-starter, because if I can't even plug it in a simple way without it coming loose or coming off, that's a design flaw. So I fixed that design flaw in the final version, and that's the one that currently sits on my desk and it works perfectly. I ended up programming it with WLED, which is a fantastic process. It is really, if you've never done it, it's about as pain-free as possible, straightforward. Shout out to the devs for making that possible, because you can program your own LEDs and your own effects and go through that, but realistically, unless you have the time to do that, it's just not feasible from a energy investment standpoint, to go through that when there's already this fantastic foundation that exists with WLED. So with WLED, Home Assistant, and ESPHome, I've been able to create the devices I always wished of having. So the simple things of like a temp and humidity sensor, it's simple in nature, but being able to see it and have it trigger different events and automation, it just opens a whole new world of possibility. So with the LED component now, I feel at a good place. I'm at a good place to where I can program my own LEDs and simple structures if I need to, using the Arduino IDE. That's what I've been using. However, using WLED allows me the app connectivity as well as the integration into Home Assistant, which Home Assistant, I'm brand new into that world. In reality, I'm still learning. I didn't even know what a YAML file was, or YAML code configuration file. So I'm still learning and just diving into that universe, and it's so vast and so expanding. There's so many possibilities, but the LEDs are so important because, of course, LEDs can indicate status, they can indicate conditions, they can indicate all types of things in a way that doesn't really require a screen. And so now moving forward, I'm able to design and integrate these LED components into my projects, and I'm going to continue to push the limits to kind of determine where the limit is in terms of integrating it with local other circuits and sensors, and figuring out kind of where that line is. Because like I said, up until this point, LEDs were super intimidating to me, but because of the copycat design evolution, trying to take an existing product and create it myself, I think you have to consider and think about some of the same things that the original designers went through when they originally designed the original product that you're trying to copy. So by doing so, you put yourself into that frame of mind, and you kind of have to work through some of the same problems. I had to play around with the LED distance. So for instance, if I put the LEDs too close to the front diffuser, then you could begin to see the pixels. And so even though the pixels were super dense, I was using a super dense pixel strip. It was like 144 pixels and per, it's like a 3 foot. I think it was like a 3.3 foot. So probably 1 meter strip, 144 pixels, something like that. But basically it was a high density pixel strip. So you really shouldn't be able to see the pixels. However, you were able to just because of how close the diffuser was. So I had to play with the diffuser distance. I also wanted to create some type of a faux heat sink. I'm not really running these at full white brightness, which is where you're gonna draw the most power from LEDs. And when you get into power with LEDs, that's something that can get drastically complicated fast, especially when you're talking about power injection and having to inject power at different points to ensure that the entire strip is getting enough power. And that to me is still largely overwhelming. So I've kind of decided for now to stick with the smaller things that kind of require simple, like a simple wall plug DC converter that's just doing, 5 volt, 10 amps, or basic stuff like that. I haven't really delve into the larger LED projects that require the crazy power supplies or anything like that. And I feel like I'll get there. But for now, I'm extremely happy with where I'm at, because when I started, I had no experience with any LEDs, anything of that nature. And like I said, for me, it was just overwhelming, but I decided to just jump in. And I think that having a finished product to copy and to emulate gave me a great starting point, because it made a lot of decisions for me. So in terms of like dimensions and all those other things, I just took that from it originally. And then once I went through all the multiple design iterations, I probably went through 20 different variants realistically. And once I got to the final variant, the final form factor and shape and functionality that I liked, then I knew, okay, again, I'm at a good place. Of course, there's always going to be improvements. There's always going to be a way to improve it. But I feel that in your heart, as a designer, as a material scientist, engineer, all these things, there's a point when you reach kind of diminishing returns. Anything beyond that, it's like, yeah, I could design that, but that may take another 8 hours, or I have to redesign the back housing or the casing to accommodate this other element. And it's just like, you could do that, but at some point you have to stop. And I like to kind of stop while I'm ahead, in essence. So everything's working, everything's functional. I love it. Can it be improved? Of course, always. But where it's at in its current state, I'm happy with. I enjoy it. And I think that's ultimately what it's about at the end of the day. It's about creating things that you enjoy and having fun while doing so, because there's no sense in making your own stuff and learning how to make your own stuff if you're going to be angry while doing it, because not a lot of people get to experience the satisfaction of when it works and when it clicks in. Like, the failure, you have to be able to accommodate and to accept the failure, because that's the biggest piece of the design game, is going through multiple iterations. So my best advice and my mantra for life is to fail faster. Fail as fast as you can, because the more you fail, the more you will get closer to the ways that work. And unless you work out those design kinks, unless you work out those design flaws through failure and iteration and feedback and figuring out what works and what doesn't, it will take you lifetimes, to make these simple decisions that you could have just learned in stride through failure. And that's the core of this message, is just fail faster. So I'll be back to do another design brief with a few other of my projects that I'm working on. But yeah, everything for me is about iterations and getting to a place of contentness with what I've designed. It's a difficult thing because it's something that you want to be proud of what you designed. You want to be able to show it off, and that requires a certain level of confidence in your design. That requires a certain level of confidence in your ability to design. Because if you are not able to, again, like let's say I just settled when I knew that when it plugged in twice, the whole thing popped off. Like if I sold that to a consumer, that would be unethical of me, because I, as the designer, knew, hey, when they plug this in 2 times, which is completely unreasonable, like for something to break after being plugged in twice. But if I acted like, oh, no, my design's good. Oh, it works. We lab tested it. Then that again would make me an unethical company, because I knew it had a design flaw and I still shipped it that way. And I could have done something about it. So did it take me longer? Did I have to go through more iterations? Yes. But at the end of the day, by not taking those shortcuts, I now have a better product and I'm able to deliver more value. And ultimately, that's what it should be about, is delivering the most value in the most efficient way, because it is a balance. And you can go crazy with offering value, but then it's no longer efficient. It's no longer economical. So it becomes a balance of how can we strike the perfect quality at the perfect quantity so that we can produce this at scale, but still be able to remain on the positive side of the ethical things and not get lost into the kind of planned obsolescence, into just allowing things to break and just allowing the consumer to deal with that. My design philosophy is that I believe in delivering the best available product at the time. And again, going back to that balance of, I want to utilize the best sensors that are available to me, the best data that's available to me, but everything comes at a cost. And so understanding that I wouldn't sacrifice or in any way degrade the integrity of my product just for the sale or the aesthetic, the aesthetic nature of, oh, this looks great, but it doesn't work great. To me, you have to first make it function and then you make it sexy. That's pretty much the design philosophy of every giant company. First, they make something functional, and then they make it sexy down the line. They dress it up, they add the UI, they add the animations, all the fancy things that make people feel more immersed. But initially, it's about making it function. So once you can make it function, then you can make it sexy. But today, fell faster. Peace.